We are going to look at ZDX Architecture. Let's look at the architecture at a very high level. On the top, we have the destination applications, which are configured to be monitored under ZDX, say Box.com or Office.com in this example. At the bottom, we have the endpoints, with ZDX enabled. And in the middle, we have the ZDX infrastructure. We just listed some key infrastructure elements here. The first one is TPG, which is the Telemetry and Policy Gateway, and the ZDX Analytics Engine. Once a monitored application is configured in ZDX, it is sent to the ZDX client for probing. Now the ZDX client goes ahead and probes the application every 5 minutes as a default interval, and collects probing data from those requests sent out to those applications. That data is then sent out back to the TPG, the Telemetry and Policy Gateway, which then is sent to the ZDX Analytics Engine, which analyzes the data and feeds into the ZDX dashboard. Moving on further, there are two types of applications that can be configured for monitoring with ZDX. The first one is predefined applications that are templates for commonly used cloud-based applications, such as SharePoint Online, Box, Salesforce, etc. After you initially onboard a predefined application, ZDX will automatically create the probes for it. There may be some cases where if you are configuring a predefined application, you may need to define the tenant ID. For custom applications, as the name suggests, they're used to monitor your internal or external private applications. To enable a custom application, you must at least create one web probe. Here in this screen we are showing two main components of the application monitoring, which is configured under ZDX. The first one is the web probe, and the second one is the cloud path probe. The web probe always pulls objects from the server and is used to collect metrics like page fetch time. It collects the network fetch time of the web page from the specified URL. The DNS time represents the time it took to resolve the DNS name for the host's name specified in the web probe. The server response time measures the time to first buy. Availability is basically if that destination service is available or not, and it's binary, it's either 1 or 0. The Cloud Path Probe discovers the network elements of that application. Basically, what are the different network hops the user is taking to the destined application? It collects metrics like hop count, packet loss information for each hop, and latency information. You can also configure custom HTTP headers for some applications as they may expect it. Along with that, you can also configure custom expected HTTP response codes. So basically, when the application is probed, what is the response code you expect from that application? It's mostly left default, but you could customize it if you'd like to. And then at the bottom we have some timers, number of attempts to be made, the timeout value, and the number of redirects. Moving on to the cloud path to see in a little bit more detail. When you're configuring the cloud path, you have the option to specify your protocol. If you choose adaptive protocol, all protocols are tested, and the best protocol for each leg is selected via an auto-discovery process. This could result in a combination of more than one protocol for the cloud path. The factors considered for detecting the best protocol for each leg are the least latency and the least loss to the destination server. So if I'm using DP and ICMP, and I get lower latency using TCP, I'll show that in the cloud path. ICMP is selected by default, but on the internet, it may be subject to rate limiting. Here are a few of the most common cloud path scenarios, which we get using ZDX. On the top, we have the cloud path for an application being accessed directly. What that means is that the application is neither being accessed via ZPA or ZIA, it's probably bypassed. We see that we can get the local gateway the customer is using, the egress ISP IP address, and all the hops the user is taking to the destination. In the next, we are seeing the path the user is taking via ZIA. Pretty much the same details, but then now we are seeing ZIA Service Edge in the path. And the last one here is the entire cloud path for an application being accessed over ZPA. We can see the end user, the local gateway, the egress ISP information, the ZPA Service Edge, all the way to the app connector, and to the destination application. Now what we saw so far was a graphical visualization of the cloud path. But if you would like, you could also see similar information with a little bit more details in the command line view of the cloud path. This is very similar to the output from the tracer command. The first call shows the list of all the IP addresses of all the hops, the hop direction from the client to the egress IP address, from private service edge to your egress IP, which is indicated by up and down arrows. There are also ISP names, Zscaler locations, which are derived from device location information, and from our integrations with the MaxMind database. Other information which we see here is the BGPASN information, the packet loss, the latency information, and we have the standard deviation, which is the jitter information. When you see these cloud parts in the ZDXY, these cloud parts are further segmented into whole different legs. In this case for ZIA, we are showing that the application being accessed as ZIA, we have 3 different legs. The first one is from client to egress, another one is from ZIA to egress, and then the last one is ZIA public service edge to the application. .A. Similarly, for ZPA we have different leg abstractions too. Client to egress, egress to ZPA, ZPA to egress. Egress is basically the next hop from where you are exiting out onto the internet, app connector to ZPA, and then app connector to the destination application.